Hi people, today we'll learn how to use the GDC to help us graph functions. So we're gonna do question number 8, item A. And in this question, you need to sketch the function, but also locate any turning points that will help you to sketch the function and find the domain and the range. So that's it. Letter A, we have this function right here, a polynomial function. As you can see, we don't have a square root in this function. That's why you cannot see a restriction coming from the square roots. You cannot see any divisions because it's a polynomial. So since you don't have a division, you also don't have any restrictions related to division. Okay. If we need to sketch the graph of a function, notice that we don't need to draw the graph to scale, okay? Some examples are here on the top of the question, example number 6, for example. And you will see that this polynomial function, letter A, also doesn't have any restrictions related to the domain, so that's why the domain in this function is all the real numbers. But this function has a maximum. What is a maximum? This point right here. And the function cannot grow after this maximum point here because both ends of the function are going towards the bottom of the graph. So this is really the maximum, the global maximum for the function. Okay, so how do you graph the function in the letter A? So to graph the function in the letter A, we are going to draw the axis, the x-axis and the y-axis, and we need to determine the minimum, the maximum, the domain, and the range. How can we do it? So we're going to use the graphing calculator to do it. So this is my TI-84, and to graph any function, you need to press this key, y equals, and then you're going to type the function. Our function is x cubed minus 3x squared minus 9x plus 10. So we're going to type x, and then this sign right here is for exponents, cubed. We're going to press the right arrow, minus 3x squared plus, oh sorry, I think it's minus, right? So minus 9x plus 10. So yes, this is the right function. And if we want to graph this function, we are going to press graph, and you will see the graph. But we have a problem right here. What is the problem? The graphing window is cutting like the two ends of the function. So since it's cutting the two ends of the function, the maximum and the minimum are not appearing. How can you change this situation? You can just press zoom, and when you press zoom, you can press zoom out and then enter. You will see like the maximum and the minimum of the function, the two turning points that you need to locate. But like the graphing window is like too big right now. If you want to fix this problem, you can just press window and change the values by yourself. I think that negative 20 to 20 is enough. And y, same thing, like from negative 20 to 20. So we can just press enter. Okay, enter. And that's it. So we're going to press graph again. And this is our graph, a little bit better, right? Okay, so what are we going to do now? We need to find what are the maximum and the minimum values for this function. And we have a key in the calculator, especially for this. You're going to press second, and you're going to press this key on the top, like calc, that's on top of trace. So you have a lot of options to calculate key values in this function. So you have a random value, you have zeros, they're the roots of the function. You have minimum, maximum, so you're gonna choose minimum or maximum. It depends on what you want to calculate first, but these two are the turning points. The turning point can be a minimum or it can be a maximum. So let's find the maximum first. So I'm gonna press enter, and you need to set bounds. You need to set the left bound and the right bound to this minimum, to this maximum, to calculate what are these values. So I'm gonna move the cursor around the graph. So I'm moving the cursor around the graph, and I'm gonna set the left bound right here. So notice that a dotted line appeared, and I'm gonna move the cursor to the right side. So I'm gonna set another bound right here, and inside these boundaries, you will find the maximum point. That is exactly this point that my cursor is at. So in order to find this point, you just need to hit enter again. So that's the maximum. The maximum is the x coordinate, negative 0.999. That's actually 1, right? And y equals to 15. So if you want to graph this point, let's take notes first. So if you want to graph this point, you can say that the maximum is negative 1 and 15. So we're going to save those coordinates for later. But now we need to find the minimum point, the other turning point on the bottom. So we're going to do the same thing, but this time we're going to press minimum. We're going to set the left bound. So press enter. We're going to set the right bound. Every time that you need to find a minimum and a maximum, you need to set the left and the right bound. Okay. So you can see that the turning point is inside these two boundaries. So we're going to press enter again. And the turning point is x coordinate equals 3 and y coordinate equals negative 17. So we have another turning point, a minimum this time, 3, negative 17. These are the two coordinates of the turning points. Okay, and how can you graph it? You can just copy the shape of the graph, but this time you will indicate the turning points. So remember, the graph doesn't need to be to scale. So I am doing the turning point right here. I'm gonna mark the turning point like the first one, the maximum. That's negative 1, 15. And that is 3, negative 17. So 3, negative 17. That's around here. Okay, that's around here, I think. So 3 and negative 17. And we can just draw the graph like it's shown in the calculator. So we're going to draw the graph like it's shown in the calculator. It doesn't need to be perfect, okay? Just need to indicate the turning points. So if it's passing through the turning points, it's okay. And now you need to determine the domain and the range. How can you determine the domain and the range? You can determine domain and range by just noticing some things. So you can see that we don't have any restrictions for this function because it's a polynomial. And since we don't have any restrictions for the function, we can just assume that every single one of the real numbers work in the domain. So let's say that the domain is all the real numbers. You just need to write the real number symbol, okay? And the range, how can you find the range? Like, you can notice that the function is growing up indefinitely, like, and going down indefinitely. That's why we're gonna have all the values on the y-axis, and remember that the range is basically the set of all y's that we can use in a function. So you can just say that the range is also all real numbers, okay? But sometimes you're gonna have a restriction when you have only one turning point, so like that could be a maximum or minimum of the function. But for this case specifically, the graph will look like this, and it will grow like infinitely to the top and infinitely to the bottom, and you don't have any restrictions. That's how you graph the function using the TI-84 to help you. If you have a Casio calculator, I'm going to attach some links in the description, and probably it will help you with your calculator too. So if you have any questions, let me know. And I think that someone in your classroom will send you this video report or post it in Google Classroom. That's it.